Here we are with Levon Guyumjan, and you know, I'm going to pose the third question to Levon. Levon, what are we? Who are we? Why did we come about? Did a God create us? I mean, how was it that our life form came about? That's got to be everybody's big question, is who we are and where we came from.
With pleasure, I'll respond to that question. You know, what I was able to comprehend throughout my research, the atom always does things into the extreme. You know, but within extreme, if the energy is strong enough to pull, it will pull into the extreme. Now, what happens, you know, if the atom, you know, doesn't have enough strength, it won't pull. It will pull as much as it has a strength. Now, what happened, you know, as a human being, we came out from a low level of energy. The energy, which one actually passed on to us from, it came out from when you see the volcano come out, the lava. That if it stays within the water, it will survive certain energy within it. But you know, if that one stays, you know, above the ground, that lava actually energy will die off slowly. Now the energy, which one it's revive itself underneath the water, that actually it will be strong enough to start the life form.
Ah, so then there's something in it about this water. What is it that water? Can you explain how water helps elements become compounds and how that assisted life in developing?
The life is a rising energy. The energy, which one is expand constantly. You know, like let's take the trees. You know, like the trees annually, the regular tree, they accumulate 48 pounds of carbon dioxide or monoxide, you know, and they release almost 240 pounds of oxygen. I mean, if you see the ratio, you know, how big it is, the ratio, you know, what exactly mean that? They take the same amount of water out of the ground, how much they accumulate the carbon dioxide. I mean, you can see every time when the tree pulls the water out of the ground,
right.
it multiplies, it expands constantly. You know, here the scientists, one thing they're still wondering why we have so much liquid water on the surface of the earth. Now I can give you that clear question, why we have so much.
Why do we have so much water on the earth?
Because, you know, once in a lifetime, imagine, you know, all the planet Earth was covered with vegetation.
Right.
All the vegetation, they produce so much oxygen. The oxygen, when it goes into the atmosphere, obviously it will come down. When it come down with the form of rain.
Right.
And it fills up all the ground.
So it was because the earth was had so much lush vegetation on it. That's why the water came about, and it's because of the water that so much life came about. Is that right?
Yes, that's correct.
Very interesting. That is interesting. So listen, by us paving and pouring concrete all over the planet, that can't be good for us. How is that affecting all living things on this planet then?
No, the paving and pouring concrete has nothing to do with it. But as long as, you know, we don't change the ratio of the carbon dioxide within the atmosphere, it won't cause so much of a harm to us.
Are we changing the carbon dioxide in the atmosphere?
Yes, we do, because according to the current scientists, before beginning of the 1900s, the difference of the ratio of the carbon dioxide was 280 per billion, but currently it passed already 350 per billion. I mean, it's rapidly is increasing carbon dioxide within our atmosphere.
There would be like a lot of people in America call it the sweet spot, or a range that's still safe. Can you tell us what that range of safety is, or have we gone beyond the limit of that safety already?
We going already tipping point.
Wow.
That's what actually this is. Every year you're going to see now on the difference. It will grow just like a roller coaster, you know, going up and down. From hot will go cold, and from cold will go hot. When it's winter, it will be extremely cold. When it's summer, it will be extremely hot.
Are we going to be able to regulate that or re-regulate that and get it back to an optimum? I mean, through our sciences, are we going to be able to control the damage that we've done and be able to correct it?
As long as we stop dumping carbon dioxide within the atmosphere, our atmosphere slowly will recover, you know, and will come into the normal level, the one we had, you know, like before industrialization period.
Explain to me how carbon dioxide affects the atmosphere and affects the ozone layer.
Okay, carbon dioxide doesn't have the ability to accumulate moisture. What I was able to know throughout my research that the only elements that are able to accumulate moisture is oxygen, hydrogen, nitrogen, all the elements except carbon dioxide. What happens, when too much of a carbon dioxide, when there's too much of a moisture accumulates in a certain level, and there's too much of carbon dioxide, it's breaking it's breaking their bonds. It's not allowing for they accumulate fast enough and come down for more rain.
Would you say that carbon dioxide being released into the upper atmosphere is holding more moisture in, and is that moisture repelling the sun's rays coming in, or what's happening by the carbon dioxide that's restricting the sun to come in? Or
no, it's not restricting. Actually, what happened, when we have we have a low and a high pressure. You see, time of high pressure, people, they have wrong idea that, especially the current science, they think time of high pressure, what happens, the atmosphere gets heavy. The pressure, the low and the high pressure has nothing to do with our atmosphere, and the high pressure, time of high pressure, what happened, actually, the atoms, they pull together, and they interfere with the energy of the earth, which one is moving up and down, and that's what actually, it shows, on the meters, a little bit of more pressure, but actually it turned the other way around, because air gets thinner, and time of high pressure, we have more radiation passing through than time of low pressure.
So is us polluting the atmosphere and adding more carbon dioxide, is that lightening it or making it heavier, or lower pressure or higher pressure?
Well, actually, it doesn't change the weight. What it's changing, that composition of the elements within our atmosphere.
So listen, we were talking the other day about life and about sticky substances and how much more energy they have than dry substances. Can you go into a little bit of explanation on this